All right, we're going to do the energy drink analysis, how to get it, how to excel at it, how to complete it. We're going to go first to the assignment itself. Inside of this, you're going to go into your assignments, and down at the bottom, you're going to find that there is an energy drink upload. This is where you'll find the assignment itself as well as some instructions. This is also where you're going to come back and upload your document. If you want to know how to turn your handwritten document into a PDF to then upload to this assignment for me to grade, you watch that video. But this video is how to complete everything. So click on that, download it, and it'll bring you to this PDF. It's very similar to the example problem that we're going to show on this video, but the differences are that the demand equation is different, that the cost of each energy drink is only 90 cents, and that the opportunity cost of selling candy is different as well. You find out the photo is different too to help remember it, and this is a question about Arnold, and the convenience store is called the Can Can Go. Down here, you'll also notice that the answers key graph has some lines on it for you to label each of those, and we're going to use this as a way to analyze our problem. I'm not going to show you how to answer this very particular problem. Instead, I'm going to show you how to do it when the energy drinks cost something different than 90 cents and when the demand is something different than the one shown there. Let's get right into it, shall we? So we'll jump over here to our energy drink demonstration. This is the one that I did in class. This is the demand per week. Quantity demand is equal to 100 minus 10 times the price. So if we charge $10, the quantity demanded will be 0. But if we charge $9.90, the quantity demanded will be 1. In other words, if this convenience store tries to sell their energy drinks at $9.90, they'll only sell 1. But as we move down here, we'll see that the price, if they charge $8, they'll sell 20 per week. If they charge $5.90, they'll sell 41. Now, multiplying price times quantity demanded will get you your revenue. If you want to know what the math of this quantity demanded is, under this window right here of the quantity demanded, I simply put in the formula. The quantity demanded will be whatever the price is, which in this case is $9.90, times 10, and then subtract that from 100. So $99 from 100, 99 times $9.90 times 10 is 99. 100 minus 99 is 1. And let's do the same thing all the way along. If you wondered how I figured out that I needed to drop these things by 10 cents, the way I did it is I took the coefficient in front of price and divided it into 100. So I took $1, basically $1, and I took the coefficient, which was 10, and I put in equals the dollar divided by the coefficient, and that gave me 0.1, which is 10 cents. If you wanted to do it with some different number, let's say if the formula involved 5 or a 25 or something like that, then you'd still keep that as $1, but you'd change the coefficient to whatever coefficient you're using. And that would tell you how many pennies you have to drop the price in order to gain one more customer. The fixed cost is $50 per linear foot in this story, and it's also the same in your problem that you're doing for me. And the feet required for display is 1 foot here, same there. The opportunity cost, though, is a little bit different. For here, we calculated that the candy profits are $100 that we have to give up in order to put in the energy drinks. So that, along with the $50 in fixed cost, give us a total cost of $150. So the way that we illustrate that is we could either show the fixed cost here as 50, or we could show the fixed cost here of 150. And if we did it as 150, then that would still mean that the profit maximizing point is where we determined it be from before. The profit maximizing point is to charge $5.50 per energy drink, selling 45 drinks. We will make a profit of $52.50. We'll have a marginal cost of $1 and an average total cost of $4.33. There's one other piece of information that we need to discover, and that is where it does the marginal revenue equal 0. We find that it does that at the 50 or 51st unit. So if we were to label the quantity at the x-axis where the marginal revenue crosses over at 0, we would label it as either 50 or 51. And that's how we would complete that part of the assignment for demonstration. Now let me show you how we build it right from the get-go. This is a special video-only example, folks, for those watching this video. I make the demand equal to quantity demanded is 200 minus 20p. The wholesale cost per unit is $1.25. The fixed cost per linear foot is going to be $80. We're going to need 2 feet of display, so therefore the opportunity cost is $280. That is to say, it's 180 candy profits foregone because we analyzed how we did that, and we're going to also have $50 per linear foot. Let's say, for instance, that for candy, weekly revenues are, let's just say they're $500, and let's also say that the weekly cost for candy is $410. Then therefore the amount of profit that we have is equal to the 500 minus the 410 for candy. Or that is, each foot of candy shelf is making us $90 in profit. So if we were to move 2 feet out of candy to put in energy drinks, then we got to make at least $180 to make up for the candy profit we lost. Plus, since we're using 2 feet, we're going to use 50 feet times 2, or $100 there. So that's $280 in opportunity cost. So let's put that in there. If we put in the quantity demanded is equal to 200 minus 20 times whatever the price is, then we have the formula that we need to fill that all in. If I take that and I drag that all the way down to, I don't know how far I'm going to have to go, so I'll just go into the, several hundred down here, 300 or 400, that'll be good. And all I've done is put in the formula for that. What the heck happened? Oh, I see what happened. So we're going to change this up here. So if I now charge $10, I can see that by charging $10, that my quantity demand will be 0. But if I drop it by a nickel, and we used that before, $1, right? And the coefficient in front of here is 20. So if I divide 1 by 20, I get 5 cents. And that 5 cents is the amount that I have to drop my price by in order to get one more customer. Now as you build these Excel sheets, they don't make sense necessarily at first, but we're going to fill it out. So here for the fixed cost, we're going to change that to $280, and that's going to be the same all the way down. And then we're also going to see where we go from here. So let's take that and fill it in, and we see that what we're doing is we're dropping the price down by a nickel every time. And as we drop it by a nickel every time, we gain another customer. See, like at $8.10, we'll get 38 cans sold, but if we drop the price to $8.05, we'll sell 39 cans a week. So to figure out which one of those is best, we will go back up here to our revenue column, and we put in revenue is equal to the price that we're charging times the number of cans that we sell. So if we just double click on that, we'll fill it in, we can see that our revenue amount is increasing, although it's increasing at a decreasing rate, which is what marginal revenue is about. Marginal revenue is the amount of extra revenue we're making by selling one more can. Here we go from 0 revenue to $9.95, so our marginal revenue is $9.95. If we continue that through, if we sell one more can, we'll make $19.80, which is $9.85 more than we were making before. If we go to something that's easy enough to, like, say $2.55 is what we make if we sell 30 cans. If we lower our price to $8.45, we'll sell 31 cans, which means we'll make $261.95 in revenue, which is $6.95 when we were making before. That's what marginal revenue is. So it fills that in right there. We can't do profit yet, but we can come over to marginal cost. We see that the wholesale cost per unit of each of these is $1.25. So our marginal cost we're gonna put in as just to avoid confusion. I'm going to say that the marginal cost, of course, of the first can is $1.25. The reason I say $1.25 here is because I know that each can I sell costs me $1.25. So the marginal cost of selling one more can is always going to be $1.25. So I'll fill that in, and it goes all the way down low. All right, now our fixed cost is $2.80, and just like all fixed costs and problems, whatever our fixed costs are, it'll stay the same all the way down at every different output point. So our variable cost is going to be a culmination of every can that we sell. So if we only sell one can, our variable cost is only $1.25 because cans in this problem are $1.25. But if we were to put in the formula, we'd say that the variable cost is going to equal, take a look up here, as $1.25 times however many we sell. However many we sell in this window is N11. We sell 2, it's 2 times $1.25. We sell 3, it's 3 times $1.25, and so forth. So if we go down to, say, like 10, now 10 units sold should be $12.50, and it is. So we're fine. We've calculated it well. Our total cost is a combination of our total variable cost along with our total fixed cost. So adding those two numbers together, fixed cost plus variable cost, will give us our total cost. We double that together and we can see that total cost is increasing by the same amount that the variable cost is increasing, not surprisingly, because we have a pretty high fixed cost to start off, but after that it's only $1.25 to sell. You know, like you might say it cost us $281 to sell the first one, but it only costs $1.25 to sell the next one. That's why our marginal costs are only going up by $1.25. You might also say that that first one is actually, equal to that, because our marginal cost of selling none is none, even though there is in fact a cost to doing that, because we didn't sell any product, so that top one is always kind of a meaningless number. But the next one is important. The very first one we sell cost us $281.25. $1.25 for the drink, $280 in combined opportunity costs and fixed costs. Our profit, of course, would be terrible then if you're only bring in $1.20. We sold it for $9.95, so we brought in $9.95. But it cost us $281, so we lose a lot of money. Whenever you see it in red or parentheses, it means you're losing money. So the profit here, which we're very interested in, is going to be negative until, and perhaps if it always stays negative, and it might be staying negative it doesn't. But if it stayed negative the entire time, then the answer to the question, how many should we put on our shelves? The answer is 0. We shouldn't try to sell energy drinks. But we have some positive numbers here, and since these positive numbers have taken into consideration already the amount of candy profit we're losing, then it makes sense to sell them. And where the numbers are continuing to go up, we keep going until we hit the top. It looks like we're close to the top. Yep, we hit it. 102.80 seems to be it. We have two different choices here to make 102.80 in profit. We could either charge $5.65 for these energy drinks and sell 87 of them, or charge $5.60 and sell 88 of them. Since more movement is better, this runs 88, so the profit is the same. So we're going to use something else to decide whether to charge $5.65 or $5.60. Well, we'd like to be known as a low price leader. We'd like to have 88 visitors per week rather than only 87. They might come in and buy other stuff while they're there. So volume and market share is better. So for those reasons, you could make the argument that charging $5.60 is the right price, and getting 88 customers, 88 sales of 88 cans of energy drinks sold per week is the right amount. That's also probably explains why we need to have 2 feet, because we're really moving out a lot of product every day. Our revenue would be that. Our marginal revenue is that. Our profit is that. We're gonna go with this as our answer. Now, how do you convert this answer over to the answer that we're looking for here? You don't have to fill that out or submit it. This is what you have to submit. You have to answer these 5 questions, and then you have to fill out this graph using that information that we have. In order to make that a little bit easier, we came over here to the... All right, so here's where we're going. Should they sell energy drinks? And the answer is yes. All right, as I'm trying this out using that. So what price should they charge? I believe it was $5.60. How many units will they sell? I believe we're going to sell 88 of them. How much accounting profit will be made each week with energy drinks? I think that was 102. We got to go back and look at it. And let me see, 560. It was going to be 102.80. Very good. So how much accounting profit and how much economic profit? Oh, well, we got to figure that out. So if we come back here, we say, which one is that? And if we didn't account for the lost candy sales, then we'd have to now. But since that did account for the candy sales, that 102.80 is actually economic profit. So the economic profit is 102.80. But because the accountant wouldn't have considered that candy loss as a cost, it's an implicit cost, they would say that the $180 that we made to cover the candy cost is in fact part of my profit. So it would have been candy profit. This time it's just accounting profit along with the 102. So we do the 180 that we forgot in candy plus the 102.80 gives us a total of $282.80 in accounting profit. That's how we would do that. And so we would write that in there, and that's how we'd go. Hopefully your penmanship is better than my my finger on the touchpad in doing this, but it still is educational. And we got to do we're really going to venture into some fun waters here. We're going to fill out this part of it as well. So first of all, this up here is, I got to change over to, let's say this. We're going to change... We got to label all the axes. So let's label the axis right here as dollar amounts. We'll label this axis right down there as quantity. Again, I hope your penmanship is better. Then what we have is we got to label these curves. The downward sloping curve on the top is the demand for energy drinks. This curve, please write better than me. This curve right here that moves along here, that's the ATC. This flat curve right here, that is the marginal cost. And because you know that the marginal cost for our drinks is $1.25, then that's what explains why at every quantity the marginal cost remains at $1.25. And then down here, this green line that crosses over the x-axis and goes into the negative territory, that must be the marginal revenue. If you pay attention to this arrow that I'm indicating right here, that arrow is pointing to the intersection point. And so if we go back to our spreadsheet, we'll see that the intersection point for the marginal revenue is right after the 100th one. So at 100, we're at marginal revenue of 5 cents, and at 101, we're at marginal revenue of negative 5 cents. So we can say that number right there is 100 or 101. Either one I would accept. You got the right concept down. I'm going to put down 100 for this because I like nice round numbers. All right. And you should try to make it fit inside the arrow, please. You can print this up, you write it on there. I just wanted to make the video streamlined, so that's why I'm setting it up like this. So here we're figuring out what the best price, we already figured out the best price, but how many units do we sell? It's 88, so we indicate that on our graph by showing 88 right here. And we furthermore indicate that since this point is where marginal revenue and marginal cost cross, that's what makes that the profit maximizing quantity. Right? The profit maximizing quantity is 88. You take that up to here, to the ATC, and that's our ATC at 88 units. We see over here that our average total cost has not been calculated yet, so we're going to put that in as equals whatever our total cost is divided by however many units we're selling. And our average total cost is $4.43. So we'll put in $4.43 there. And furthermore, take that quantity line straight on up to the demand curve, and if we're going to sell 88 cans a week, then we can charge the price that this market is willing to pay, and we already know that that's $5.60. And that's how you do it. So you would fill out in a nicer way, once again, all of the graph pieces, and then you would upload it as a completed handwritten document that you scanned in to complete it. Hope this helped, and have a great day.